Welcome pre-cal students to the homework help video, page 70, numbers 1 through 11 odd, 15 through 25 odd. Let's go ahead and get out your work and see if we can't answer your questions. Okay, problem numbers 1 and 3, the directions say to graph and label the given points. Okay, I'm not going to spend a lot of time on this. It's pretty easy. Let's plot 4, 0. That would go right here. Let's plot -3, -5. That's over 3 and then down 5. Let's plot, I'll cross each one off as I do it. -1, 4. So -1 to the left and then up 4. 0, 2. So I'm at 0 on the x and then I go up 2, 0, 2. 2, -2. I go over 2 and down 2, and there we go. So we plotted those 5 points. Let's take a look at number 3. My first ordered pair is -5, 1. So over 5, up 1, positive 1. 5, 1. Over 5, up 1. 2, 3. Over 2, up 3. 2, -1. Over 2, down 1. And 0, 1. So I'm at 0 on the x-axis and I go up 1. There we go. Okay, let's read the directions now for number 5. Express the data pictured in the graph as ordered pairs, letting the first coordinate be the year. So I'm going to write that down right here. The first coordinate of your ordered pair would be the year. Okay, I'm just reading the directions right now. And the second coordinate would be the amount. So there's your ordered pairs. So this would be your x-axis, this would be your y. So what that means is this axis here. Now watch carefully. This is going to be your year axis, and this axis here, which is the second one, would be your amount. In other words, the first number is always going to be with your horizontal axis, and the second number is always going to be your vertical axis. Now, we could look at 2000 as a 0, 2001 as a 1, 2002 as a 2, 2003 as a 3, 2004 as a 4, and 2005 as a 5. We could look at the amount. It's already in millions, so 310, 311. We better put these increments here in increments of 100. So on the vertical axis going up and down, each one of these tick marks is going to be worth 100. Going down, it's going to be worth -100. Okay. Now your horizontal axis, your year axis, those will be your normal increments of 1. Mr. Earhart, can you do that? Can you have one axis be in one increment and the other axis be in a different increments? Most definitely. Nothing wrong with that at all. Okay, so your first ordered pair is going to be 0, 310.6. Do you see that? In the year 2000, and I believe this is how much total advertisement was spent for the NCAA basketball tournament, there was $310.6 million spent. So that's your first ordered pair. Your next ordered pair is 1, 311.2. Your next ordered pair would be 2, 348.2, and the next ordered pair would be 3, 361.6. Your next ordered pair would be 4, 435.8, and your last ordered pair would be 5, 467.7. Now if you're saying, Mr. Earhart, let me get a drink here real quick. If you're saying, Mr. Earhart, how did you know to put the years first and the money second? Well, right up here, remember in the directions they told us that if you'll read the directions, it says let your first coordinate be the year and the second coordinate the amount. So now that I've laid it out, here we go. We're at 0 and then 310. Well, 100, 200, 300 would be barely above that line. We're just estimating. I'm not looking for perfection. And then we're over at 1 and then 311, which is basically the same height going up. And then we're over at 2, and then we go up 348. That would be about right there. And then we go over 3 and we go up 361, so it'd be a tad higher. And then we go over 4 and we go up to 435. So 1, 2, 3, 435 would be about right there. And then we go over 5, and we go up 467, so about right there. So that's it, okay? It's almost a linear relationship. Don't those ordered pairs almost line up in a straight line? Almost, but of course we estimated too, so nothing's perfect. But we took these 5 ordered pairs and we plotted them, and that helps people make estimations in the future as to how much money will be spent on advertising. All right, let's continue on to number 7. Now number 7, they want you to test this ordered pair and say yes or no, and then test this ordered pair and say yes or no. So let's start off with the first ordered pair. Y equals 2x minus 3. Where the y is, I will substitute a -1. And where the x is, I will substitute a 1. Let's see if we get a true statement. -1 equals, not sure why I put 2 equal signs, there we go. -1 equals -1. So this would be a yes, it checked. Okay, 2 times 1 is 2, minus 3 is a -1. Now let's substitute the same ordered pairs into this equation here. So where the y, now we're going to use this ordered pair, 0, 3. So where the y is, I will put a 3. Where the x is, I will put a 0. And you end up with 3 equals -3. That is not accurate. No, that ordered pair does not satisfy the equation. Number 9. Okay, let's go ahead and substitute. Let's use this ordered pair first right here. So where the x is, I'm going to substitute 2/3. And where the y is, I'm going to substitute 3/4. Now you can use a calculator if you need to. 6 times 2/3 is 4. 4 times 3/4 is 3. And 4 minus 3 is 1. 1 equals 1. So, yes, the first ordered pair does satisfy the equation. Now let's try our next ordered pair. 6 times 1 minus 4 times 3/2 equals 1. Well, 6 times 1 is 6, and 4 times 3/2 is 6. So 6 minus 6 equals 1, 0 equals 1. No, that's not true. So the answer would be no for this ordered pair. All right, let's move on to number 11. Let's go ahead and start off with this first ordered pair. Now let me stop and say, I know we have an A and a B, so in that case you go in alphabetical order. So A comes first in the alphabet, so your first number is an A, and then your second number is a B. Okay, that's how you do that when it's not an X and a Y. So having gone over that, let's take our first ordered pair here and let's substitute it in. For the A, I'm going to put a -1/2, and for the B, I'm going to put a -4/5. A positive times a negative is negative. 2 times 1/2 is 1. A positive times a negative is negative. And 5 times 4/5 would be -4. Obviously, it's not going to work. A -1 and a -4 is a -5. -5 does not equal -3. So this ordered pair here is a no. Now, let's check this ordered pair right here. Where the A is, I will substitute a 0. And where the B is, I will substitute 3/5. 2 times 0 is 0. 5 times 3/5 is 3. And that is true. 0 plus 3 is 3. 3 does equal 3. So this ordered pair is a yes. It does satisfy this equation. All right, moving on to number 13. Let me check the book here. I believe that this is a 2 right here. Yes, it is. And I'm not sure why they give us these really weird decimals. A little bit of a pain there, but that's okay. Let's go ahead and take this ordered pair right here, and let's substitute it in. Now notice we have some squared variables, no big deal. So I would have -0.75 squared minus 2.75 squared equals 3. Now, I'm going to go ahead and just use fractions. 0.75 is the same thing as 3/4. So a -3/4 times a -3/4 is a positive 9/16. Now you're welcome to keep your decimal. I'm just going to use fractions. I don't have a calculator with me, so that's why I'm doing it this way. Okay, 2.75 is 2 3/4, which is 11/4. And so if you square those, you would get 121 over 16 equals 3. Okay, 9 minus 121. There's no way this is going to work because you're going to get a negative number. I mean, 9 is smaller than 121. So 9 minus 121 would be negative 112 over 16. I really don't care what decimal that is because it's not even close to being 3. So this ordered pair right here does not work. It is a no. All right. Now let's go ahead and evaluate this ordered pair. So where the x is, I will substitute a 2. And where the y is, I will substitute a negative 1. Well, 2 times 2 is 4. Minus, now when you square a negative 1, you get a positive 1. So 1 times 1 is 1. And obviously 4 minus a positive 1 is 3. And 3 does equal 3. So this ordered pair here does satisfy the equation. Okay? All right, moving right along. Let's take a look now at number 15. Numbers 15, 17, and 19. The directions read, find the intercepts and then graph. So we should know how to do that. Where the x is, I substitute a 0. And where the y is, I substitute a 0. Okay, if we do our math here, 5 times 0 is 0. 0 minus 3y is negative 3y. Divide both sides by negative 3. Y equals 5. So the y-intercept is 5. 5x, 3 times 0 is 0. 5x minus 0 is 5x. Divide both sides by 5. And x equals negative 3. So that's your x-intercept. There we go. All right, so this is the y-intercept. This is the x-intercept. That's where the line crosses the y-axis at. This is where the line crosses the x-axis at, and you draw your line. A pretty popular and easy method to use. Okay, number 17, where the x is, I'm going to substitute a 0. And if you simplify this, you will get y equals 4. If you substitute 0 in for y, and then simplify this, you will get x equals 2. I'm skipping quite a few steps, but this is pre-calc class, and you should know definitely how to do these simplifications. So there's your line. Pretty simple, guys. Okay, number 19. All right, where the y, I'm going to put the 0 in for y first. It really doesn't matter. Okay, if I simplify this, notice I substitute a 0 in for y to get the x-intercept. And if I simplify this, I will get x equals negative 4. So that is my x-axis, negative 4. Now where the x is, I will substitute a 0. And if you simplify this correctly, you will get y equals 3. So my y-intercept is 3. And I kind of missed the point there when I drew the line, but there we go. Okay, let me get a drink here, and that's how you graph those. They're pretty simple. Okay, moving on to 21. Here the directions say just to graph. If you use the double intercept method where you put a 0 in for x and a 0 in for y, that's fine, but you know on your quiz coming up, on your tests and quizzes in the future, you will have to know how to do the plotting points or the table of values method, whatever you want to call it. So I'm going to use this method on the next 3 problems, and then we're done with the homework assignment. I always put in 0, 1, and 2. That's me. Now I'm not going to do all the math for you. Again, you're pre-calc students. This should be very easy for you. If you put a 0 in for x, you will get out of 5. If you put a 1 in for x, you will get out an 8. And if you put a 2 in for x, you will get out an 11. Now I'm going to have to add some points or some tick marks to my table of values here. 1, 2, 3, 4, 5, 6, 7. 8, 9, 10, 11. There we go. Okay, my first ordered pair is 0, 5. My second ordered pair is 1, 8. and my third ordered pair is 2, 11. So those three points should line up in a straight line, and they do. And so there is the graphed line. This is called the table of values method or the plotting points method, whatever you would like to call it. Okay, and there's your 3 ordered pairs. All right, 2 more problems. Let's take a look at this one. Again, we're going to use the table of values. You can put any 3x values in that you choose. I like to use 0, 1, and 2. If I put a 0 in for x, I will get out a -3. Watch your signs there. If I put a 1 in for x, let's see, bring it over. That would give me a 2, so a -2. If I put a 2 in for x, I will get out a -1. So my first ordered pair is 0, -3. My next ordered pair is 1, -2. And my next ordered pair is 2, -1. And there we go. That is the line I get when I plot those 3 points. Okay, one more problem and we are finished. So not a very difficult assignment in my opinion. And I'm not sure why I put that extra space there. All right, here we go. Now, I like to use 0, 1, and 2, and I've taught you that. But sometimes there's exceptions. I noticed I have a fraction here beside my x, and so I'm going to put in 0, 4, and 8. And the reason I'm going to do that is that will help me get out whole numbers instead of fractions. Now listen, if you used 0, 1, and 2, that totally works. You have a calculator and it will spit out the fractions you need over here, and that's fine. In fact, I think what I'm going to do is I'm going to very quickly use both table of values and show you get the same line either way. So first of all, I'm going to substitute in 0, 1, and 2. If you put a 0 in for x, you will get out a 3. If you put a 1 in for x, you will get out 2 and 1/4. And if you put a 2 in for x, I've got to work this out here, you would get 1, 2, -1.5. You would get out 1.5. Okay, so I'm going to plot these 3 points: 0, 3, over 1, up 2.25, and then over 2, up 1.5. Now next what I'm going to do is I'm going to draw the line that goes through these points like that, and let me extend it a little bit, and then move it so it's right on those points. That's pretty good. Now there's the line. Okay, no problems with that, pretty simple. Now here's what I'm going to do. I'm now going to put these 3 numbers in for x up here, and you're going to see the points I get out. The points I get out are going to fall right on this same line. So I'm trying to show you either way is fine. I just would have preferred quickly using these because there's no fraction. If I put a 0 in for x, I'll get out a 3. If I put a 4 in for x, I get out 0. And if I put an 8 in for x, I would get out let's see, 2, -6, a -3. Now let's see if these ordered pairs fall on the line. 0, 3 is right here. 4, 0 is right here, so it barely missed it, but you do understand my line wasn't drawn perfectly, so that's totally acceptable. And then 8, -3, 3, 3, 6, 7, 8, so here's 8, and then down -3, 1, 2, 3, let's make sure I did this correctly, 8, 2, negative. Yeah, it's off a little bit more than I would have liked. But to be honest with you, when you look at this line, if it was slid down so that it hit the x-axis right there, it would be right at 8, and then -3 would be right there. I mean, it's right on the line almost. So either table of values that you would have used would give you the exact same line. Okay, I hope that this homework help video has been a help to you. Call or email if you have any questions.